Greetings, Chem 110H, Dr. Bevilacqua here. I'm going to show you a way to visualize the atomic orbitals for the hydrogen atom. What you want to do is open up a web browser and go to the class website. I'm using Safari. I'm on a Macintosh. I found that this works better. I wasn't able to get it to work on Google Chrome. So if you're in Safari, go ahead and scroll right down to the bottom. And you'll find this link right here called a cool website for visualizing atomic orbitals of the hydrogen atom and diatomic molecular orbitals. Go ahead and click on the atomic orbitals. The one for molecular orbitals we can use in a few weeks. And an applet will pop up. I'm going to go ahead and bring it up here. Now the first time I tried this, it did not pop up. I got a warning from Java asking whether I trusted this site. I knew I could trust this site, so I said yes. If it doesn't work for you, you may need to update your Safari or update your Java. So I'll go ahead and I'll stretch this to size. And I'm going to go ahead and change the principal quantum number here to 1. And I go ahead and I have the 1s, and I can see that it's spherically symmetrical, and I can see its densest in the core and that it thins out as I move radially away from the nucleus. I'll go ahead and I will increment the principal quantum number to 2. And now I see I have the 2s and the 2p. Here's the 2s, and I can see that there's two different colors. I'm going to stop the animations because all it does is change the color. It really doesn't do a whole lot for us, so we'll wait for a good color to come around, maybe right about there, and we'll stop it. And we can see where the nodes are. I can go ahead and I can draw them for you. And there is one radial node, and it's where the color changes or where the sign changes, and it's right here. Okay, and so if we put plus in the center, then when we pass over this node, which is a radial node, then the sign changes like so. Now I can also go up here under View, and I can choose Radial Distribution, and it'll show me down below the radial distribution. I'm just going to lower the height of this a little bit, and I can see here my one radial node. So let's go ahead and increment L to 1 so that we now have the 2p. And with the 2p, there's one planar node and no radial nodes. We can see the absence of radial nodes here. And here's our one planar node. This is the 2pz. And so the plane is going to be the xy plane. And that is right here. And the sign changes when we cross that planar node. And I can grab this guy and I can twirl it around in this program. So now Z, as it is right now, Z is vertical, but I can make Z come out of the computer screen so that I'm looking right along the top, right through to the bottom of the orbital, and I'll go ahead and tip it back. And you can look at other p orbitals. You could look at the 2px, and now it's oriented along the x axis and so on. Put it back to the 2pz, you can do slicing. So I can look at an x slice. When I look at an x slice, what I'm doing is I'm looking along the yz plane, and there it is right there. There's the slice, and I can do that. And that's kind of fun and interesting to look at. So I'll turn the slicing off. Now I'm going to go ahead here and try and tip that guy back as best as I can. And I'm going to go and I'm going to increment n to 3. And so now I have the 3 S, P, and D that I can look at. Let's go ahead and start with the 3S. And I'm going to go ahead and rescale this guy a little bit, like so. You can also change the resolution. It's getting a little pixelated, so I can improve that. It just sometimes slows your computer down a little bit. If I go down here and I look at the radial distribution, I can see my two radial nodes, and I can see them up here because the color changes. And so if I go ahead and I look at that guy, then I can see that pull this up. Okay, that I have my two radial nodes. There's one, and there's the second one, and the sign changes whenever I cross them, like so. Now I can go ahead and I can look at the 3p. I'll increment L to 1. And so now I have my one gained radial node, and I still have the same planar node. Remember that the angular portion of the p PZ does not change when n increases from 2 to 3. We saw that in class. So I'll go ahead and I'll write those nodes in here. Here's the same planar node, which is the xy plane, and then here is the radial node. And if I make this plus and this minus, then whenever I cross a node, whether it be a planar node like here or a radial node like here, the sign changes. So those are my algebraic signs. So let me go back now and increment L to 2, and so now I have the 3D. And you can see here's the famous one with kind of the donut. If I tip it, you can see it. There's no radial portion, and that's what we expect because we know the first time that we saw an S or a P, there also was no radial portion. This has 2 conal nodes. Let's go back to a little bit more ordinary 3D orbital. Let's take the 3D xz, and we'll do it so that the y-axis is coming in and out of the computer screen. And because it's a n equals 3, there must be 2 nodes, and here they're both planar, and we can see them pretty readily like so, and the sign changes whenever we cross one of those planar nodes. So we can go ahead now, and for fun, we can let n increment to 4. And let's walk through these guys. So we'll start with the 4s. Let me scale that a little bit. And we can see because n is 4, we should have 3 radial nodes, and you can see them 1, 2, 3. You can see the color changing. If we go to the 4PZ, we can see now that we have 2 radial nodes, 1, 2, and we still have our 1 planar node, which is in the xy plane. And we can go ahead and quickly write those out. There's our planar node. Here's radial node 1, radial node 2. Sign changes every time we cross over a node. So now let's go ahead to the to the 4D, and I'm going to pick the 4D xz, and we can see that it's picked up a radial node just like we expect. And we can go ahead and do the sign on this. Here's our 2 planar nodes. Here's our gained radial node. If we put sign here as positive, then as we cross these planar nodes, the sign's going to change. And then if we move inside from outside to inside, we're crossing a radial node, the sign must change. And now, once we're in here, we're going to cross these planar nodes again, and the sign's going to change. Okay. So that is your 4D. And let's go ahead and take a look at a 4F. Again, the first time we encounter a new type of orbital, we don't see any radial nodes. This guy has a complex set of nodes. Let's go to one that's a little bit more ordinary. This is the 4F xz squared, and we can see clearly the 3 planar nodes. 1, 2, 3, and the sign changes every time we cross. Okay, so that's this website. I hope you found this insightful. Please check it out. It's fun to play around with, and I think you'll learn quite a lot from doing that. And thanks for watching.